so that it becomes easier for anyone who has missed the call. So let me introduce Maria. So Maria is from Greece, and she works in one of the ministries over there. And she was kind enough to join us today as a motivational speaker because I wanted. So we have a lot of Saudi students over here from Almaarefa University in Riyadh and also from elsewhere. And these students are very sharp, they're very bright, and they are learning neuroscience and AI. And we are hoping to empower them, especially the female students, so that they can get more education, they can make a career, they can move forward. That is the primary reason I invited Maria to come today, because I wish that she give us a little bit of introduction about herself, about her education, about the work that she is doing, so that some of our students can look up to her and idolize her, and inshallah follow in her footsteps one day. So I'll just quickly give it to Maria. Maria, please go ahead.
I would like to thank you, Ahmad, for this invitation. It's a great honor for me to join your session, and I hope I can give you all I know about the way I think and work. Well, first of all, I live in Greece. I am a teacher in a high school, and where I teach biology and microbiology, following my first degree, which is associated with biomedical sciences.
Tell us a little bit about your interest in dementia and Alzheimer's.
Okay. Well, during my first postgraduate in public health, I contact one of my academic teachers, and we conducted a certain project which was related with aging. And a life expectancy which increases, and that is associated a lot with neurodegenerative diseases like Alzheimer's. So when I finished this project, I came across NCAI via LinkedIn. And then I saw and realized that there are people, experts, AI experts, and companies like NCAI, and they have certain tools to improve lives of people with Alzheimer's disease and dementia. At the moment, I would like to tell you that I'm running a project on bioethics dilemmas related to carers to people who take care of patients with Alzheimer and many kinds of dementias.
Tell us a little bit more about this project. What sort of work are you doing in this, and who will it help?
I can hear you, please.
A little bit more about this project that you're doing, who it is going to help. Are you helping patients? Is it research?
It is a research project.
Uh-huh.
I never thought that I will be in such a project. I mean, I knew about Alzheimer's, although my family does have elderly people, but
Yep.
I'm lucky they are not Alzheimer patients. But because of the increasing number of people lived with dementia, I wanted uh, to take this research to help uh, mainly even my Greek government there with certain proposals,
Yeah.
um, such as you do with your tools.
Yes. Yes. And how did
Because
you? And when you came across our company, Neurocognit AI, NCAI, how did you like it? How did you feel about it?
that people, I think that people who cooperate with you are very lucky. And I think you do so good to Saudi Arabian people. Um, uh, I spoke about this tool to a friend of mine who is a neurologist
Hmm.
here in Agrinio.
Uh-huh.
And he told me that someone could, uh, excuse me,
That's okay. That's okay. We have non-English speakers over here, so we completely understand. That's okay.
yeah, okay.
So your
Um,
colleague of yours, he also knows about our company.
excuse me?
This colleague of yours, he also knows about our company, NCAI.
Yes,
Okay, that's very good. Well, what we can do is we can share more information and more tools that he can use. If he's a neurologist, these tools can be very
yes,
helpful for him, and we can give him access to some of our development, and maybe he can use it to help his patients. So I think that can be very
yes,
good.
yes, 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 yes.
Perfect, perfect, perfect. So thank you for joining us today, Maria. It was a pleasure to have you, and
Thank you, thank you. Good luck to all of you.
thank
Good,
you. Thank you so much. And we will give you
goodbye.
a recording of this call as well. So you can keep it, you can share it with your friends on LinkedIn here and there. And
Thank you,
you're welcome. Bye bye.
thank you, thank you.
Bye.
Bye bye.
Okay, so Mr. Azam, back over to you. I see we have some students who have joined in. Haifa, Ida, Dalia, Hasib is here, Melissa, and there's Zeninisto, and there's four other people. So that's good. We've got a good turnout. I think more. Ahmed is here, Ahmed Shalabi, and I was talking to an Ahmed on WhatsApp just 5 minutes ago. Maybe it's him. Okay, Renard is here as well. So this is very good. Azam, I'll hand it over to you so you can please start with your training session. Thank you.
Uh, okay, wait, I share the screen.
Just to let everyone know that today's session is going to
Yeah,
be is going to be an
uh,
on AI, and towards the later half of it, thank you, Ahmed, but I'm not a doctor, but thank you for your kind words. But towards the later half of it, we're going to focus on our research and the research publication that we are working on, and how we're going to give some of you tasks so that you can also contribute towards that publication in terms of research. And Azam has prepared a presentation for you guys.
yeah, are you see my screen?
Yes, we can see it, but have you started the PowerPoint? No, not yet.
Yeah,
Okay.
yeah, I'm
Oh,
starting
oh,
now.
okay, we can see it now. So he has made a presentation for you guys. I have shared a PDF of the presentation in the group chat as well. So you guys can later on look at it as well. But Azam is going through with it. So Azam, please over to you.
Okay, Ahmad bhai. Uh, First of all, welcome to all the new students for the platform of Neurocognit AI. Today, the main focus of the presentation is some brief introduction about the artificial intelligence and how the artificial intelligence embed in deep learning, generative AI, and agentic AI model. Uh, Now, first of all, what is AI? As you all people know that AI is basically the intelligence of the computer provided by in the form of code, yeah, in the form of routines. and the routines make the decision on the basis of reasoning and some other things. This is a basic overview of artificial intelligence. And there is a brief evolution of artificial intelligence. Basically, the artificial intelligence started in the 50s and moved forward to 60s, 70s. But the basic hype of the artificial intelligence and embedding of the artificial intelligence from 2007, when the program algorithms and different type of software, automation software, just like decision support systems and other software which are used in the industry, high-tech industry, like the automotive, mobiles, medical, healthcare, and other animal else. Now the evolution start from 2007, and the idea when the deep learning and the machine learning models come in the market, then the boom is on the way. Now, where the artificial intelligence is used, particularly the artificial intelligence is used in every field of life, especially supply chain system and the banking sector, research and development, and nowadays the every field of life and every industry use the artificial intelligence in the form.
Excuse me, Azam, I'm just going to cut you. So I will speak about this slide a little bit. I want to give some insight to the students about how things are working in Canada and the
Mm,
evolution of AI in all these fields in Canada as well.
yeah,
So
yeah.
to start from the top, so customer service was one of the first few things that AI sort of took over. So they had a lot of autonomous robots that were being developed in that part of the world, in North America and Canada, although some in Europe as well. And what they wanted to do is they wanted to use AI in two aspects over there, not only in the navigation systems, but also in how the robots would converse with humans. So we actually did a project. We did a autonomous robot disinfection robot project. So this was after during COVID-19. So we built these autonomous robots which would move around on their own and they would disinfect surfaces, and they would also, in the second phase, it was planned that they would interact with humans as well. Now, there's different things that AI has been used with. So we used it in, for example, we made quality control systems, the manufacturing sector, that would optimize supply chains in Canada. So we've used it over there, and now it's been used everywhere. So banks are using it for fraud detection. So if someone misuses your credit card through AI, the banks know, okay, you know what? This person doesn't spend money over here usually. Why is it he or she spending money over here? That's how they track it down. It's being used in human resource management systems, HRIS. It's been used in obviously in R&D. We're doing R&D over here. It's being used in health tech, predictive analytics. A lot of it we are using as well because we're trying to predict Alzheimer's disease. Again, for customer insights, it's used again for risk management. So there's a lot of, it's multifaceted. It can be used anywhere essentially now. And a lot of organizations are making it an aim that they want to infuse and instill Alzheimer's into their production processes. Not necessarily production, but also in other various aspects like customer service, or whether it is internal company management. So a lot of it is going on. It's being used in training programs as well, like this one, for example. So back to you, Azam. Thank you.
Now, so Ahmad explained you all the relative tasks and where the AI is used. Specifically, the diagram also show you the areas. Now move forward. Uh, Now the next thing is that introduction of AI level, which level we are standing and which level the industry moving forward. We are in the era of three type of artificial intelligence era. We are in the era of artificial intelligence, narrow intelligence. Nowadays, the generative AI models and some other models like deep learning models falls in the artificial narrow intelligence. And the second area is artificial super intelligence. The supercomputer or nanocomputers, yeah, the computing in the defense systems and some other system where the competition level is too much high. The intelligence things are used in such industry. And the last thing is AGI, artificial general intelligence. This is the main thing. which are moving forward to the industry. Basically, these things are to manage the things of narrow brains of the humans, just like the human brain. All the things are managed through AGI, and this is a futuristic type of revolution of tech. But some pros and cons of such technology. That's why this technology is not a publicware, but some firms are already working on that. Now, the other thing is that there are three, the major sphere is artificial intelligence, but the artificial intelligence narrow down to major things: machine learning and deep learning. In 1960s, the machine learning models, basically the machine learning models are differentiated from the normal programs as that. In normal programs, we are define some routine checks, and our programs are working according to our routine checks. But in case of machine learning, our programs are run from routine checks, but also learns the data and take the decisions from learning more learning data and premature that after more data learning. Similarly, the deep learning is the advanced form of machine learning, because in machine learning cases, machine learnings are not properly read from image and some audio and video level data. But in deep learning, such flaws are also covered. Some convolutional neural network and autoencoders and transformers. Such models are updated in the deep learning models.
Uh,
And
I'm just going to add something over here, Razam. Okay, so to give you a practical example on how you can differentiate between machine learning and deep learning, so I'll give you an example of one of the projects that we did in Canada. So this was for a company called Automotive Sunroof Craft, and these guys would have Toyota manufactured cars that would come in, and the dealers would request that an sunroof be added to these vehicles aftermarket. So when the vehicle, the car, the automobile, when it left the factory, it did not have a sunroof. But when it came to the dealers wanted sunroofs installed to add features to the car. So then they would send vehicles to this call this this well, not a manufacturer, it was an aftermarket fitment shop, or called Automotive Sunroof Craft. And now they wanted to use AI to optimize that process. So what we did was we built a system for them, which first went through all the car models that existed, and then it went through the specifications of the sunroofs that they had. So where the placement of the sunroof was, what was the size of the sunroof in terms of length and width, and all the technical details over there. Then you feed that all of that into the model and you train the model. Another example of that was visual inspection. So we did another project which was a quality control based project, which was for this factory which was making PPE gowns. So you know those gowns that doctors and surgeons wear. So there was a high demand for them during COVID-19. But the problem was that quality control was a major issue, because sometimes the gowns wouldn't get stitched properly and would pass a visual inspection. And if it got to a hospital in a state that was not proper, then that could lead to infections for both the doctor and the patients. So we made this system for them, and it was simple. So we taught the system. How do we teach the system? So we give the system a lot of data. We give them a lot of pictures of properly stitched gowns, and then pictures of improperly stitched gowns, which is not stitched properly. So you have to teach the system that this is correct and this is wrong. Once you throw enough data into the model starts learning, okay, this is right and this is wrong. And then that's how it can differentiate. This is very similar to the concept that we are now using in Alzheimer's detection. What we're doing is we're teaching the model on hundreds of thousands of images of patients who have gone through MRI and fMRI exams and amyloid PET scans. So we are teaching the model that, okay, this MRI belongs to a patient which has Alzheimer's, and this fMRI belongs to a patient who has mild cognitive impairment, and this is a MRI of a normal patient, and this is the MRI of a patient who has advanced onset of dementia and Alzheimer's. So once we throw enough data into the model and train it, then it starts picking out, when you give it a random fMRI, it can look it up in the database that it has, and it can tell you whether it matches to a fMRI, which is normal or which is diseased or not, and which level of disease is it at. So that concept essentially is being used over and over and over again. It's just getting more and more and more refined. And now, obviously, with the onset of AI agents and RAG, retrieval and augmented generation, and these medical LLMs, it gets better for us because first we can run it through our model, get a preliminary diagnosis, and then we can extract the best information from these medical LLMs. Back to you, Azam. Thank you.
Okay, now I move forward after the era of the machine learning and deep learning model. There is evolution of generative AI. Generative AI is a sequel of the deep learning, but in case of deep learning, we train the model, and after the large amount of training data, our model provide better results. But in case of generative AI, there is a new thing is that we create a new contents from our patterns of data, some like that. We have a textual data, and we create a new textual data from the patterns of already available data, similar to images, audios, and videos. As you define that, generative AI is a type of artificial intelligence to create new contents like text, images, videos, based on the patterns of data. This is the evolution, and this evolution is embedded in the form of large language model, which is abbreviated as LLMs. As the LLM era is come in the market when the ChatGPT is launched in 2022 in the web portal versions and also the app version, and then the LLM models come to the market like Gemini model, like Cloudy, Anthropy, and DeepSeek, and now new generative AI models come into the market, and we move forward that. Now the era is from generative AI start from 2010, but not is mature. The maturity level is to 2022, but the working on the large language model is come from 2017 to 2022, when OpenAI company working on such models and create such models. Because these models are very state of the art, and then the maturity of the models is different. Agents and agentic AI era is come in the field. Now, now the agentic AI era is that we perform in a in case of generative AI, a simple chatbot. We talk the chatbot and put our query in the form of chatbot, and chatbot gives the information from the given textual data, and sometimes apply some reasoning factor on that. But in case of agentic AI, the different chatbots, different agents come perform the same task, same like the era of the autonomous chatbot. But in case of agentic AI, not one agent is working in that. There are different type of agent interact with different LLM models and different APIs, and some different of software, and different local models and the global models, and provide the information, the interpretation of the interpretation in the form of RAG formatted and other things. When we deeply talk about this thing, then you understand better about how the agentic AI flow is working. That now we move forward to that. A simple example is that because in agentic AI, different AI agents works, and the key characteristics of AI agent, the agent has autonomy, the agent works on goal oriented thing, the agent also perceptions just like the human perceive the things, and is also apply the reasoning and decision making powers. It's just like act like the simple human person act like that. You see the first example, the AI agent architecture. You see that the AI agent architecture interact from local files, interact for databases, user inputs given to that, and interact also the APIs. And after the all the things, they give the output. to the user. And similarly, AI agents also observes, act, think, program, and perceive just like a human. When we give the input from human, the human mind also perceive the things, and after the perception, they act and thinking and observations there about the information, just like the AI agent working that.
I'm just going to add something over here, Azam.
Yeah, yeah,
Think of an agentic AI agent. So this is the in thing at the moment. This is the thing that everyone is chasing because it gives you a model which is completely autonomous, which can do its own work without any supervision, and it can give you results. So what there's an even thing called an AI agent slash employee that companies want to now make. They want to make agents who will work for the company like employees, and they will generate their own tasks and perform those tasks, and then so it's a very crazy time right now because a lot of this is going on, and a lot of companies are trying to invest in more and more R&D into this stuff. So an AI agent is as the features as you can see. There was a I'll give you an example for those of you who watch movies or like movies. There was a Will Smith movie called I, Robot, if you remember. That movie involved these guys who were building robots, and eventually the robots took over the city, and the robot developed a mind of its own. So, although that was a negative example of the same thing, but it's a very similar concept that essentially the system makes it it gets a mind of its own, and it starts doing its own work. Obviously, it remains within the guidelines that it's been provided by the company, but it creates its own tasks and it performs those tasks and so on and so forth. So this is something that is very, very popular these days, and you see the word AI agents everywhere. And Azam will talk more about it. Thank you, Azam.
now we move forward. The major difference between the AI agent and the simple chatbot. In simple chatbot have no intelligence, more intelligence feature because they do not react for reasoning. The agentic AI pattern also adopt the reasoning and provide the things on dynamically more efficiently, like the simple autonomous report. And second thing is flexibility. The in case of agentic AI, learns and improve real-time based interaction for different APIs and different databases. Similar to that, we also build the model, and after the our model give the inference in the form of classifications and some explanation AI features. Then we move past to such information from our agent, and our agent interact from the different LLMs and gather the data. And after gathering the data, they apply the RAG feature because retrieval augmentation, and the RAG feature summarize in the form of abstract and give the relevance information to the user in the form of output through textual data in the form of graphs, some images, and anything else. And other thing is decision making. Decision power is more updated in case of simple report. And the last thing is business impact. This is a very important feature because the business point of view, the agentic AI just like play a role of as an autonomous employee, just like the healthcare assistant, just like some other ticketing agent, and other examples are also available. That now we move forward that some deep learning models, and basically in deep learning models we are in case of Alzheimer narrow imaging, we deal different type of modalities like MRIs, fMRIs, PET amyloids, taus, and some geoinformation data, some genetic data. And the convolutional neural network CNN models are architecture is very popular because these models are very popular, and these are the advanced form of the neural networks which learns betterly from the pixels and other features extractions of the images slices. And after they build a model, and after they give the classification of these over the desired results. Now we move forward that basically we also design such pattern. uh, Basically you have when you give the multimodal model, then you give the input in the multimodalities. Like that we are also make a model, because we are making different type of model. We also build a single modality model, but at the last I am also building a multimodal model which takes the three type of inputs like PET amyloid, MRI, and fMRIs. And after taking the input, they pass on to the deep learning based Alzheimer models. And these are the different type of Alzheimer models. And basically in our product, we are using a fusion model. Basically, fusion model is a combination of convolution neural networks and autoencoders. And these models are very famous, and the results of the models are very efficient in case of the multimodalities. And also the your data sets are also in multi-coherent, because when you feed over model in the practical point of view, you observe the things for different type of coherent. Because if we are train the model from different coherent means different geographic area, we get a model of Saudi Arabia person, we give a European person, and some other labs which are different areas of regions and different continents. Then our models training level is too much enhanced, because the brain structures of different type regions of people are different. Because the peoples of Asians brains are different, like the Chinese people, and the European people's brains are different, and similarly the Gulf people. That's why we are taking different coherents. And basically the top coherent and top data set is ADNI, OSIS, and some other uh, sets are also we are used for training our model. Then we move forward to another pattern. Basically this pattern is when we train our data from a single type of current but different multi-class, because we train our model for different classes of the some modality. In case in such example, we take MRI and we take input of the dementia, Alzheimer disease. And basically the dementia has four major categories. First is mild dementia, moderate dementia, very mild dementia, and not dementia. Then I move when we get the modalities inputs from the MRI, in the case of 3D slices to 2D slices. Then we move forward to the images from the data pre-processing phase, like the image processing. You see that in image processing, we are using resizing, sharpening, and the image augmentation like rotation, scaling, and other blur, other features apply in that. And after that, we um, and after that you see that we have different, we split our data into the form of testing and training phase. Basically we can, it is the basic requirement of the convocation network to splitting our data from testing and training phase. And now we split our data as a ratio of 20/80, and it depends upon you. You take a 90/10 ratio also. And after that we fine tune some routines, apply the fine tune and some transfer learning techniques. Because you see that the efficient net b free network, this is basically a transfer learning approach. We also use a other transfer learning models. And after that, the combination of that, we construct our model, which is you call that your proposed model. And after the training of your proposed model, you get the analytics of different evaluation metrics, like the accuracy of the model, the sensitivity of the model, the specificity of the model, the AUC curve, and other things. And after that, when your model is trained, that you give the real input and your model is classified You see that our model is classify the Alzheimer disease classification. When you give the image, your model categorize that which category falls the Alzheimer disease, like mild, moderate, very mild, yeah, in case of non-dementia. And after that, you apply the explanation AI. Basically, the localization gradient cam, gradient cam plus plus. These are the explanation AI methods which clearly identify the which area is prominent. You see that in general images are in black and white gray features, and you do not observe betterly that which area is prominent. But in case of gradient cam feature, you see that different spots, yellowish and reddish area, and some bluish area, sacrifice that which area is affected for Alzheimer. Now I move some other example. Basically, this is other example is because this example is very hot nowadays. This is the fusion model. In fusion model, basically we built a two different type of hierarchical model. In example, we take two input modalities. The first input modality is MRI and fMRI, and the second is, which is currently, is a PET amyloid. And we put the things in the convolution network, and after that we built two networks. One is convolution neural network and other is encoder model. And after getting the features of both the models, we concatenate the features, and after concatenate the features, we extract the classify that which persons are healthy and which persons are belongs to Alzheimer disease. Basically, this is a idea for those people how the models are built, and how which type of modalities and which type of data we uh, pro- uh, put on the models, and how which type of results we get from the models, and how we the structure and the different parts of the model, working of the model. But in deeply, these things are everything have a depth, and we cover that in the future lectures. um, Now the other session is about our research work. Now
Uh,
it
uh,
pass on
Sorry,
this.
before you start, I'm just going to add something over here. So, guys, the slide number 12, 13, 14, 15, these last four slides, do not get confused by it and do not get overwhelmed by it. We've sent you the PDF so you can have a look at it later on as well. Try to study it, try to make sense of it. In the upcoming lectures, we will also be going through the application of all this. So we'll be actually showing you practically our model, how it is being developed, and all of this that you see on paper right now in theory is going to be shown to you practically as well. What coding is being used, how the coding is applied, how the different aspects and steps of neuro pre-processing are taking place, and with the videos and the graphs and the dissections and everything. So this is very high level right now. This is introduction, but keep in mind that this whole training session, this whole cohort is focused on practicality. So we're going to be sharing with you practically how these things are done. So we have the machines installed at King Saud University. We will remotely access them. We will show you how the softwares work. Yes, Abdulaziz, we use CNN type of analysis. And we're going to show you all the softwares that we have. We are going to show you the in-house softwares, proprietary softwares that we're developing, the AI models and algorithms. And so don't get confused by it, but it's good that you have the PDF so you can study it later. Now, this next half is going to focus on our research, how it is moving forward, how you guys can contribute to it. There are some students who are very interested and they message me, like Haifa and Melissa, I believe, and the other students as well. I'm forgetting a few names, but a lot of people message me about specifically about the research. So this is especially for them if they're attending this call. Some of them are, I see, and then others who are going to watch the recording. So so just bear in mind, this is what time is it? I think it's about 34, 35 minutes since we started the lecture. So whoever is watching it later on can start from this point of time if they want to focus on the research part. So Azam, please go ahead. Thank you.
Okay. Now the research perspective about the neuroimaging regarding the building of model, the interpretation of your model in the form of explanation AI, and also you build the agents from your inference of your model. These type of research are very hot in the market, and the areas define that first is that you build a machine, a deep learning model, a framework for the classification and interpretation of any neuroimaging disease. Particularly, we are dealing the Alzheimer because in neuro, the Alzheimer is a hot disease, and many research work is also applying on the Alzheimer. The other diseases are Parkinson. The Parkinson are similar to Alzheimer, but the Alzheimer symptoms are too much high, and the other is the brain tumors and other things, but we are specifically focused on Alzheimer, and Alzheimer data sets and coherence and biomarkers are very hot, and many organizations and many societies are working on the Alzheimer. Recently, the annual conference also organized by organization, I forgot his name, that because recent their conference is launched in Denmark, and also participate in many organizations and companies that for your models and other things that, and inshallah we also participate in next conference. Um, then the second thing is that we compare, also make a comparison of multi-coherent data sets. You take multiple data sets like the ADNI, because ADNI have a lot of data about the Alzheimer's, and every modality like MRI, fMRI, PET, and tau, because the PET and tau are do the blood biomarkers, just like serums which are injected in the form in the blood, and these are showing after neuroimaging the protein things on the brain. And the other is that we also built a single या multi models. Just like that, we built a one convolution neural network, and other is encoder. Yeah, we built two neural networks, and after give their can generate that some better feature extractions, and take some multimodalities like you take MRI, fMRI both. Yeah, you take the PET amyloid and MRI, and also tau, and also reverse engineering that. Many things are available in the internet, but I suggest that first of all you people learn about the simple and systematic review of the particle neuroimaging model framework or disease, because these are the informations in the systematic review papers give you the detailed information about the particular models of your framework, your disease, and you get many such questions, and you better understand that which level of research is focused at, and you which level you achieve that, because when you build something that you also understand that your contribution of the research, this is the basic thing. First of all you analysis that, and in the next slide we have a comprehensive overview about the deep learning radiomics of neuroimaging for Alzheimer disease diagnosis. First of
Azam,
all,
Azam, sorry, before you start, I'm just going to add something over here really quickly for 2 minutes.
yeah,
Okay,
yeah,
guys, keep in mind that what we are doing is we are developing an AI-driven diagnostic tool for Alzheimer's. Okay, so currently, what is happening? Currently, what happens if a patient goes to a doctor? The doctor will ask them questions, and the patient will say, "Oh, I'm forgetting stuff, and I'm having cognitive decline." The doctor will say, "Okay, you know what? It could be one of many things. Let's get some tests done." So the first test that they get done is usually MRI or fMRI. That test costs about 700 riyals at King Faisal Hospital at the moment. It's basic MRI they get done. The MRI currently does not tell you if you have Alzheimer's or not, but the doctors can use it to rule out other ailments such as aneurysms or internal bleeding, because sometimes these ailments cause and mimic the same symptoms as Alzheimer's. So after the fMRI, the doctor says, okay, you know what? It's not an aneurysm, it's not internal bleeding, no tumor. So it might be Alzheimer's, but he's still not sure. So the next step is, depending on how far the patient has progressed. So the next step is the amyloid PET exam and the tau. Now, that exam is the gold standard test for Alzheimer's right now. It is expensive. It costs about 12,250 riyals at King Faisal Hospital currently. And it is also invasive. So what they do is they inject a radioactive tracer into your bloodstream. It travels all the way up to your brain, and then you get PET scanning done, imaging done. And if there is a buildup of protein in the brain called amyloid, and then this tau protein as well. So if there is buildup of that in the brain, the scan will highlight it. Now, those are the proteins that cause Alzheimer's. Okay, they're a symptom of Alzheimer's. So you have to understand that currently it is so difficult and so expensive to just diagnose this disease, and it can only be done once the amyloid and tau proteins have developed in the brain. So early diagnosis is not possible. Now, our system, how we are training our AI model, so we got pairs of data. So we got a patient X, let's say, and they gave us a fMRI of that patient. Now, when the patient went to the doctor, they got the fMRI done. fMRI could not tell if it was Alzheimer's or not. Then the same patient went to the same doctor and said, okay, you know what? I want the gold standard test. The gold standard test was the amyloid PET. They had the amyloid PET scan done, and then the PET scan came back with the result, whether it was early onset of Alzheimer's or advanced or whatever the result was. But now we know that the fMRI of that patient was actually the fMRI of that patient who had Alzheimer's. Okay, that is how we are training a model. Now, connect this with my earlier statement about how we are building quality control systems and so on in Canada, and the pass fail I was telling you about. So it's very similar over here. So we train it with pairs of data. We give them the fMRI of the patients and the amyloid PET scans of the patients, and then we teach the system, okay, you know what? Now we know this fMRI belongs to a patient who tested positive during amyloid PET. So once we feed enough data into the model, there will come a time that the model from a simple fMRI will be able to predict whether the patient had a positive amyloid PET scan in terms of Alzheimer's or not. So get my point? So that's how we are taking this forward. So this is just for an overview of how we are approaching it. But this is a very simplified version that I'm telling you. It's going to get a lot more complicated. Azam, back to you. Thank you.
Now, these are the modalities. Sir Ahmed also explained that why we are using such modalities. A very simple modality is MRI, basically the structural MRIs, SMRIs, and basically the biomarker feature we extract from MRI is brain entropy. Brain entropy is mean the brain gray and white area and the cells, and after that the result is detect the volumetric changes using voxel-based analysis. Means the tissue shrinkness and the hippocampus shrinkness. These all things are we analysis through explanation AI from through the brain entropy. And the second thing is that the fMRI. In case of fMRI, because the fMRI is the advanced form of MRI, and this is 4D, the time series data is also connected, and the neural connectivity features are also available in that. Now in case when neural connectivity features are identify the microstructural abnormals like the texture analysis. These are the basic goals. And the third thing is DTI. The DTI is not recently used by people because these DTIs also give you the white matter integrity. And in the past, the people combine the MRIs with the PETs images, and by using DTIs for the combination, but these features are not utilized by the recent research. And the other thing is amyloid PET. It is a gold standard test. And basically, the amyloid PET is the earliest version, and the second is the tau PET. This both are the gold standard test, and though both are used for injecting the pressure in the blood, and after that visualizing through neuroimaging. We also visualize that the proteins figures are the plasma are injected on the cells where the Alzheimer's symptoms are occur. And the other thing is also the FDG. This is also the type of amyloid PETs. The other thing like glucose metabolism. And basically the amyloid PET and tau is basically used. FTCC is also used, but many cases the amyloid and tau PET is used for biotracers. And now we move forward. Basically, these are the research questions and motivations for the Alzheimer disease diagnosis. The people who wants to make research on the Alzheimer or other narrow disease. Basically, these are the basic questions. The first question, basically, these questions are made people like you. It's are not the at the last thing. The other question are not generated by research, but these are the questions which are very commonly, and you must follow that when you build some research perspectives. First question is that what multimodal data combinations are used in the detection of Alzheimer disease? Which type of multimodal data? First thing is that which data sets are used, which modalities are you use, and how which level of output you get that. And the motivation is that to know how complementary modality improves the prediction. It's not just like that you make a model, a simple convolution neural network, and you get three modalities, because the three modalities are not handled by the single convolution neural networks. Because in case when you get the three modalities, you make a fusion model, and you also make some encoders, get transformers like that to handle that things. These things are very important. The second is that what datasets and pre-processing methods are used for multimodal data handling. This is also a very important question. If you take a PET amyloid data, you must have some other pre-processing steps, extra pre-processing step applied from such image rather than normal MRIs. And you apply some built-in pipelines, just like the fMRI prep is a very good pipeline for pre-processing of data. And other is the FSL library, also available. Basically, it's the first library which ensure that you're pre-processing. And other is the Clinica is recently another good library for the pre-processing of data, because these are libraries are also using for training and pre-processing of a model. That's, and in future lectures I also give you some practical examples, and also share some code work. The people who are interested for such code, they utilize that. And the third question is that what methods are used for multimodal fusion in Alzheimer? Basically, when we apply some model, the methods and feature extraction techniques are also important, because you justify that. Uh, the main thing is that when you write a paper, uh, you also write up three to four bullet points. Your contribution of this, your model contribute that the community of research. Basically, these things are evaluated by the other the person which are your evaluator, because before the publication, your paper is evaluated by some good researcher in the platform of IEEE, in the platform of Science Direct, Springer, the top uh, uh, top research paper publishers. And after that, which different AI models are available for AI diagnosis? You also know that which are the models already, because you when you write up your research paper, you also give the references of the other related works, because you are not just people who worked at in some reason. When you deal from the PhD level, yeah, you deal some um, other thing which are not the public thing, not open source, use such thing. But in common cases, you also give some other people's work, and you relate that your work, and you after that you also give the reason that you the already some people's late search results month over model is predicted more accurately, and the efficiency and accuracy level is approximately high 1%, 0.05, 2% at your depend on your model. And the other is very question number 5 is a very useful question: which explanation AI framework are used to implement model? Because the explanation AI is also the gold standard of the interpretation of your model, because you just classify the things, and after that you give that the accuracy level. It's not a good thing, because if you give the interpretation of your framework in the form of some interpretation framework model like the gradient cam plus plus lamb model shape, other different evaluation things are available, it justify your model. And you see that the motivation is that to explore how explanation AI techniques enhance trust, transparency, and model validations. And after that, you after you performance of your trend of your AI model, and in the last, the limitation, challenges, and also the future scope of using your multimodal data and your explanation method, how your model contribute to the world. These are the basic things. Um, Now I pass on to Sir Ahmad and the people's regarding the question about that.
Thank you, Azam. So yeah, I have one or two questions about the research questions and the motivation. So the students are now expected to go and research these questions and come up with responses, correct?
Yeah,
Okay, perfect, perfect. Guys, I'll move it over to you. I know Haifa might have a few questions, and Melissa, and all the others as well. For those of you who are interested in the research and are not on this call right now, you can just go through the recording, and then you can privately send us your questions and queries so we can address them, myself and Mr. Azam. If there are generic questions which can benefit everyone, then I suggest you post them in the group so that the answer can be utilized by everyone. So that makes it easier for us rather than messaging everyone one by one. But obviously, if it's a one-on-one question, you can always send it to me or Mr. Azam directly as well. Now, guys, if you have any questions about this or the rest of the lecture or anything else, please go ahead. Okay, so one of the major things. So I'm gonna give you a very small example over here, and I hope it will help you. So I was at York University, Canada. This was the year 2008, and we had a professor called Professor Huang. Um, Guy from China. He was like 4 feet tall, and he was very eccentric. So sometimes he would be wearing mismatching shoes. There was always something going on with him. So long story short, first day at his lecture, I was late. We were young back then, and there was a friend who came over, and we were just chatting, um, and suddenly I looked at the time. I was late for the lecture, so I went anyways, and I took this friend of mine with me, even though he was not a part of the class at all. He was a part of the university, but not of that specific class. And we went, and in the class we saw three of our very good friends over there by chance. So there were high fives going on, we were hugging, meeting each other, clapping. And this guy became angry. He says, this is a lecture and you're just walking in, meeting your old friends and this and that. I just remembered him because he had the worst rating as a professor. There was a website, Rate My Prof, and everyone would go and say, don't take this course, this guy is very, he's not a good professor, and this and that. Now, the first day of the session, it was a 3-month semester, and it was a 3 credit course, I remember. So the first session, he said, you know what, you aren't going to have a midterm exam, you aren't going to have a final exam, you are not going to have any take home assignments for this class, but mandatory attendance for the 12 weeks. So 12 sessions, 1 class a week. You have to come, 3-hour session. You have to sit here and listen to me. And in every session, you have to talk for 5 minutes. So we thought he was crazy, but it was a very good course. And by the end of that course, we realized what he was trying to do. He was trying to give us confidence, because in none of the other courses, none of the professors required us to speak. They would just come and speak, and if there was a question, we would just email them, and then the class would end. But this professor was very good for us, because he taught us, he gave us confidence, he taught us how to talk in public spaces. Now, I've been doing other training sessions as well with King Saud University, and I've noticed that people tend to send me written questions afterwards instead of asking it in the class over here. So that is fine, but I also like some of you guys to speak a little bit, and even if it's a English speaking issue, I understand Saudi Arabia is a non-native English speaking country, but that's fine. You can try a little bit, and we will try our best to address your questions. Haifa, I'm going to force you to talk a little bit.
Hello, Mr. Ahmed.
Assalamu alaikum, how are you?
Walaikum salam. Hi.
So hopefully you have a question for us somewhere.
Unfortunately, I don't have any questions now, if I'm being honest.
Okay, okay. How did you find the session generally? Any feedback?
Very informative.
Okay, that's good.
Really
So
nice, yeah.
one thing we've done is we've tried to keep it simple. When we started at King Saud University, we did not start at this level. If this is level 1 or 2, we started at level 5 or 6 over there. But the students were getting lost, and it was a bit tough. So then we had to bring it back down to level 1 and start again. But it took us like 3 or 4 sessions to figure that out, because the students, as I said, weren't saying anything. So I urge all of you, even if you're not speaking right now, if you have any apprehensions, if this thing is difficult for you, if you're not understanding anything, if you'd like something to be different, you can always message me later on as well, and we would obviously love to incorporate your feedback into the training session, because we're here because of you. So it's best that we try and make things as easy for you as possible. A little bit about my trip. So I'm coming on the 13th of April. So I will be there. So 2 parts. I'm there from the 13th to the 16th. Then I'm going for Umrah. So I'll be in Makkah for 2 days. Then Medina one day, and then I'll be back in Riyadh for the next week. And then I'll be in Riyadh from the 19th to the 23rd. So during that time, we will be having some events at King Saud University. I'm coming to Almaarefa University as well. At Almaarefa, we will do a small meet and greet with the students. So Mr. Saad over there, he's the one who's arranging all that. And then we have some meetings at RDIA, the Ministry of Investment, and obviously I have to go to King Faisal Specialist Hospital and Research Center, where we are doing the clinical trial pilot. Inshallah, the paperwork's going through. In Saudi Arabia, there's a lot of paperwork for everything. Everywhere you go, there's like a long line of forms and stuff that you have to fill and people you have to chase, but we're doing it, inshallah. So if any of you guys are interested in any of that, you want to go to the hospital with me, you want to go to the Ministry of Communication Information Technology, meet one of the deputy ministers, you want to go to the RDIA, meet the GM. I know it's not mandatory, but if someone wants the experience, they want to go, they're always more than welcome to join us. They can go and share their stories over there, look at their programs, what they're doing. So there's a lot of stuff we can do over there. And yeah, that's about it. So if you don't have any questions, that's okay. I see we have just skipped the 1 hour mark, so that's okay. Mr. Azam has taken a recording of the session, so we will posting that soon as well, so you guys can take a look at it. The PDF has been shared in the group, so you can take a look at the task. And I'm looking forward to see the results of the research task, actually, because that's going to be something that we are going to involve. Those are the people that we're going to involve in our R&D, in our research publication as well. Mr. Azam is working on the publication. I think he will be sharing it with us in this upcoming week. And because I have to bring it to Saudi Arabia, it means there's a few professors and doctors who want to peer review it as well. And and yeah, that's about it, guys. If you have any questions, feel free to message me. And Ahmed Shalabi, I see your comments as well. This is your first day over here, so welcome. And I got your messages on WhatsApp as well. I will be reaching out to you. I'll try my best tonight, inshallah. And yeah, that's about it, Mr. Azam. Thank you very very much for the session today, and it was very good. I feel. And inshallah, and thank you for Maria as well for coming on from Greece. So every week I'm going to try and get an international speaker to come on to our calls so that you guys can get international exposure as well. That remember, if someone new comes, always go on LinkedIn, always add them, message them, because that is one more person that you add to your network. And you never know where these people might be helpful for you in the future. So before I leave, a reminder to you guys to go on LinkedIn as well. Please follow our page. Please like our posts. Comment on it positively if you can. And inshallah, we will be in touch soon and see you guys next week. Thank you very much. Thank you, Mr. Azam. Thank you. Allah Hafiz. Bye bye.
Allah Hafiz, Ahmad bhai.
Thank
Hafiz.
you.